Okay, today class we will be learning how to draw an atom, and it is also called the electron configuration of an atom. We will be able to draw as well as to write what that electron configuration is. Now when we are drawing the nucleus, all you have to do is just draw the nucleus of the atom showing how many protons and neutrons are inside. And we've already learned how to figure out the number of protons and the number of neutrons as well as electrons in any atom as long as we have access to the periodic table. So, for example, with the lithium atom, we know that that is number 3 on the periodic table, so we have 3 protons, and we also know that it has 3 electrons. And in order to find the number of neutrons, we just have to subtract the atomic mass, which is 7, minus the atomic number, which is 3, and then we get the neutrons, which is 4. It can be represented such as this for the nucleus, with the protons having 3 and the neutrons being 4. Or you can also just draw each individual neutron and proton. Notice that the N stands for neutral and the positives are the positive charge for the protons. Now when we're talking about electrons can be found in something called an electron shell. An electron shell is the number of orbits or energy levels that exist around the nucleus of an atom where we find electrons. The number of shells is determined by the period number, which are just the rows of the periodic table of that element. So if you were to look at the periodic table, and remember that a period is the rows of the table, nitrogen is located in the second row, so we say it is in the second period, and it has 2 electron shells. And remember, an electron shell is just an area around the nucleus. So here we have 1 and 2 electron shells because nitrogen is in period 2. For magnesium, if you were to look at the periodic table, it is in the third row, or period 3 of the periodic table, and therefore it should have 3 shells, 1, 2, and 3, where electrons are held. Here is a periodic table for you to look at, and remember that periods are each row. So in this row we have hydrogen, and we have helium in row 1. Over here we have lithium, beryllium, boron, carbon, nitrogen in row 2. Period 3 has sodium, magnesium, aluminum, silicon, and so on. And then we have period 4, 5, and so on. Now if we look over here at helium, we know that helium is in the first period, so it has only 1 shell where its electrons can be. With oxygen, we see that it is located in the second row, which is known as the second period, and therefore it will have 2 orbital shells or energy levels, and so that is oxygen. For magnesium, we know that that is in the third period. So the third row means that there will be 3 orbitals or 3 shells around the nucleus. So that's just to give you an idea of how to figure out how many shells or how many orbitals exist for each element. Now, when we're talking about valence electron shells, what this means is just the electrons that are located in the most outer shell of an atom. It is the number of electrons that is determined by the group number of the periodic table. And remember, the period was the rows of the periodic table. The group number is designated as the columns of the periodic table. So for example, if you were to look at your periodic table and find lithium, lithium is located in group 1. And because it is located in group 1, it has 1 valence electron. Now remember, it is also located in period 2, so we know it has 2 shells, and in the outermost shell, it is going to have 1 electron. So we say that it has 1 valence electron. Now carbon is in group 14, and so for any numbers that you see that are double digit, all you have to do is to cross out the first, and it is the last number that you care about to tell you how many electrons are in that valence shell. So for carbon, we have 14, so that means we have 4 valence electrons. So in the outer shell, we will have 4 electrons. For fluorine, this again is a double digit. We're going to X out that first one and only take the electrons, the number here, and that will give us how many electrons we have in the valence shell. So here we have 1, 2, 3, 4, 5, 6, 7 valence electrons in that valence shell. Let me show you how the groups are situated. So here's the periodic table. And we already learned that periods are the rows. So here's period 1, 2, 3, 4, and 5. And remember, those are the rows of the periodic table. And this will help you to determine how many electron shells there are for your atom. Now, when we're talking about groups, these are the columns of the periodic table. And right here we see 1 through 18. And number 3 is for scandium and titanium and vanadium, which then goes all the way through where we know for element number 5, boron, we have that being column 13, and carbon has column 14, and we have group 15, 16, 17, and 18. So this is just a representation so I can show you that these are the periods and the columns are the groups. There are a certain number of electrons that you can have in every shell. In the first shell, notice that there can only be 2. In the second and third, however, there are 8. When an atom has 8 valence electrons, it is considered stable, unless, of course, it is the first shell. Then it likes 2 electrons in that shell, and that is the most that it can hold. You will be asked to write the electron configuration for any atom, and it can be done easily as long as you have access to the periodic table. This is a written representation of how many electrons are in each electron shell. For example, if we are looking at lithium, lithium is in period 2 and in group 1. So we know that there is 2 electrons in the first shell and only 1 electron left in the valence electron shell. And that can add up to the total number of electrons. So 2 plus 1 is 3 electrons. And we can check that because we have the atomic number right here, and that is 3 electrons. Carbon is located in period 2 and group 14. So that means that we have 2 orbitals, 2 shells, right? Because we're in period 2. And remember, there's only 2 electrons that can go in the first orbital. And that would leave 4 electrons in the valence electron shell. And we can add that up. And we have 2 plus 4 is 6. And that's 6 electrons. Sodium here has 11 electrons. And it is located in period 3 and in group 1. So that means if it's in group 1, we know that there's only going to be 1 electron in that last outer shell, or the valence electron shell. So here we have the first shell has 2. The second shell, remember, wants to have 8, and that's the most that it can have. And then we have that leftover one in the valence electron shell. So we say Na 2, 8, 1. So as a repeat, if you were to write the electron configuration for lithium, it would be Li 2, 1. And that would state that there are 2 electrons in the first shell and 1 electron in the valence electron shell. For carbon, it would be C 2, 4, saying that there were 2 electrons in the first shell and 4 electrons in the valence electron shell. And again, sodium is Na 2, 8, 1, which says that there are 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the valence electron shell. Here is some examples that I would like for you to try. Write this down, and what I'd like for you to do is to write the electron configuration and to draw the electron configuration for both oxygen and for phosphorus using your periodic table. Pause the video and restart it when you're ready to check your answers. Okay, so for oxygen, let's go ahead and take a look where oxygen is located. So we know that oxygen is located in the second period. So we know that there are going to be 2 shells. And we also know that oxygen is located in the 16th group, which means there's going to be 6 valence electrons in that last shell, in the valence electron shell. So we have 2 shells and 6 in the outside. So we would say C2, because remember the inner shell, the very first shell, can only have 2, and then we have 6 more electrons. And so we're going to put 2 electrons in the first shell, and notice how they're opposite of each other. So we're trying to show that there's a balance. And then 6. So I have 1, 2, 3, 4, 5, 6 electrons in the valence electron shell. For phosphorus, we can see that phosphorus is in the 3rd column, which is period 3, and that means that there are going to be 3 electron shells, and it is located in the 15th group. And because of that, we just take the last number, and we know that that 5 means we're going to have 5 electrons in the valence electron shell. So when we write this configuration, we are going to say P for phosphorus, 2, 8, 5. And that means that in the first electron shell, we're going to have 2 electrons. The second electron shell will have 8, and we will have 5 electrons in the valence electron shell. So here we have, let's go and check this. This is the first electron shell, and that's going to have 2. And then there will be 8, 1, 2, 3, 4, 5, 6, 7, 8. And that's the second electron shell. And then we call the last shell the valence electron shell. And that is going to have 5. 1, 2, 3, 4, 5. So everything looks good. And if we wanted to just check to make sure that we had the correct number of electrons total, and remember that phosphorus has an atomic number of 15, we should have 15 electrons. So that's 2 plus 8 plus 5, and that is 15 electrons. So here are your answers for the electron configuration written and drawn for both oxygen and phosphorus. All right, we've come to the end of our video. Thank you very much for watching. This was a lot of information. Go back, re-look at your notes, make sure you understand this. You can always just start to pick the same elements that I used in my video to write the electron configuration and to draw the atom, and that way you can just check and make sure that you understand. Be ready to use this in class next. Thank you for watching.